Guys, happy Monday. A couple people have expressed to me that they're having some struggles with the plate tectonics PhET. And so what I'm going to do is just walk you guys through this following the steps on your worksheet so that hopefully it makes a little bit more sense, and if it won't run on your computer because you don't have your Java updated, you can still kind of get the gist of what's going on. So part one says begin with the crust tab. So in the top left, we're going to select crust. Under view, we want to check both and show labels. So views in the lower right hand corner, both density and temperature, and we want to show labels. So the labels that pop up are the top layer is the crust, and beneath that in darker red is the mantle. So then we have tools down here in the toolbox, and you can click and drag the tool so that you can use it to measure. You also have a thermometer and a density measurement device. So for each of the crusts, we are going to measure the thickness, the density, and the temperature. Okay, pause. My dogs unplugged my computer. That was kind of dramatic stuff, guys. Anywho, so we'll go ahead and measure, well, I guess oceanics first in the table. So let's do oceanic first. So I'm going to line up the zero marker, so the end of the ruler with the start of the light pinkish gray crust. We can see that it's somewhere between the 5 and 10 kilometer mark, so you can estimate maybe 7 or 8 kilometers thick for the oceanic crust. The density of our oceanic crust is, you can count our tick marks. So 1, 2, 3, 4, 5, 6, 7, about 8.5 for density. And then for the temperature, the oceanic crust is 2 little line ticks. And then we can move on to the continental crust. Continental crust is about 45 kilometers thick. Its density is about 7.5 ticks, and its temperature is about 2.5 ticks. So then you should be able to answer the analysis questions below. Which type has greater thickness and which type has greater density. Then using the thermometer tool, measure the temperature in the crust and the mantle, and how does that compare? Does it increase or decrease? Hi, Kino. Isn't that a great time for you to be jumping on me? Thank you, bud. Okay. So if we compare the temperature of the continental crust, about 2.5, to the mantle below that, the mantle is about 4 temperature ticks. In the oceanic crust, we had 2 ticks, and then in the mantle below there, we've got about 4 ticks. So the mantle is right about twice as hot as the crust. Okay. Now we're going to switch to the plate motion tab. So under view, we're going to click both, show labels, and then you can't actually click show seawater until you put oceanic crust on there, so that's kind of annoying. So once we get crust on there, we'll click the show seawater button. So we have 3 of our vocab terms: convergent plate boundary, divergent plate boundary, transform boundary, and subduction, just for reference up here. this says, set the simulation up with one continental and one oceanic crust. And it says it doesn't matter if the oceanic is young or old. So we'll just pick young for funsies. So now we can click show seawater. And then it says, drag the plate in the direction of the green arrow. What type of boundary is this? So since we have one plate moving into another plate, they are converging. Micah, stop turning off things. Get out. Oh. Anyway, convergent boundary. And so the oceanic plate is going under the continental crust, and so that's also called subduction. So down here, where it says insert screenshots to take a time lapse, you can kind of rewind everything so that it's reset, and then you can take a picture or like a snip at 0 million years and then let it go for a little bit. Then I would take a snip right here as we're starting to see some of the magma in the mantle interact with the water from the ocean. That's 16 million years. And then I'd go ahead and run it to completion when we see our little cutie volcanoes form, about 40, 50 million years, and then take a picture there. So you're showing the beginning, the middle of the process, and the end of the process with your screenshots. Which plate subducts? So analysis questions, and then what feature is made, and you guys should be able to figure that out. Then reset the simulation and use 2 old oceanic crusts. So I'm going to say reset all, say both, show labels, old oceanic crust, and now I'm going to drag my plates in the direction of the red arrow. So if I pull in the direction of the red arrow, our plates are moving away from each other, and young oceanic crust is starting to form in the middle. So go ahead and identify what type of boundary this is. You're going to do the same thing with your 3 screenshots. You'll start at 0 years, you'll do it about halfway through, so this is probably good, and then run it all the way to completion, which in this case is 35 million years. Okay? And then identify the feature that's been created here in the middle. So now we're going to reset and set up with 2 continental crusts. So both density and temperature. And 2 continental. And you can see in this case we have 3 directions that we could potentially move our continental crust. So it says drag it in the way of the blue arrow. So if I drag it towards me, the blue arrow, I create this boundary where the plate on the right is moving away and the plate on the left is moving towards me. So identify that type of boundary, take your screenshots after you rewind it, take your 3 screenshots to show the progression over time. You're going to do the same thing with continental crust again. And this time, you are going to drag it towards the green arrow. So you can see that they are coming towards each other, they're converging, but there's no subduction happening because they are the same density. So one plate cannot go under the other. And so that is your analysis question C, and then think about what happens to old crust and what happens to new crust when it's formed. Okay, and that is the end of your activity. So hopefully that was helpful, and you can go through and use this video to answer the questions, or you can download the PhET and do it yourself. But hopefully you guys find that really helpful.